Hello friends, Bhattacharjee Sir here. Today I'm going to discuss how to solve numericals from the flowchart from the concept of mole. Uh, Different quantities such as volume, numbers, mass, concentration, um, different types of concentration such as normality, molarity, etc. So here I'm going to show you how you can solve numericals with the help of this flowchart. Flowchart basically tells you how to reach to moles from various data given in the question. These are all, you can see this arrows all are going towards moles. These are, uh, the means to reach to the moles from the given question. And after reaching to moles, your job is to get the required values such as required mass, required volume, required number of particles, subparticles, etc. So, what we'll do, we'll keep this chart by your side and we'll take question one by one and I'll show you how to solve those numericals from this chart. Okay. So, let's take one example. So, our first example is find number of moles of copper atom in 10 to the power minus 23 atoms of copper. To solve that, we need to understand where exactly we have the given data. You can see the given data present are basically you're in that area. In that area. Let me highlight it properly. So basically you are here. Can you see it? Now your job is to get to the um, at this point. At this point. So journey is very simple. You need to move from this point to this point. I'm showing the route. Okay. So let me show you how to put all this data here. So our calculation is number of moles. So moles can be calculated like this. Moles is equal to, you need to take, number of particles that is given 10 to the power 23. And then you need to take this Avogadro's number, you need to divide it this value by the Avogadro's number that is coming out to be 6.023 into 10 to the power 23. So that will cut off and answer is 1 upon 6.023 into 10 to the power 20. That is the answer. I hope you understood that. Now let's take another example. So now going to the next question, you can see some reactions. Reaction is given chemical calcium carbonate reacts with HCl to give calcium chloride and CO2 according to the equation, blah blah blah. What mass of calcium carbonate is required to react completely with 25 ml of 0.75 molar HCl. So to do this sum, what we need to do, we need to write down the equation first. Calcium carbonate plus 2HCl giving calcium chloride plus CO2 plus H2O. Okay. Now they are saying that you can see the calcium chloride, they want how much calcium chloride will be required. So I'll put question mark here. Okay. And the data given, it is on HCl, which is basically, this is the quantity of HCl given. So if I write down the data of HCl, that is, first of all, 25 ml. Okay. and molarity they have given, that is 0.75 molar. Okay. Now, if you look at this particular equation very carefully, then you'll find calcium carbonate and HCl ratio, molar ratio is 1 is to 2. Okay. It is very much clear here. So, for some reason, if I can calculate number of moles of HCl from this, then easily I can calculate number of moles of calcium carbonate. For that reason, what I'll do, I'll see how to reach to moles from volume in ml and molarity. So volume in ml and molarity, if you check volume in ml and molarity, where it is there, you can see this. I'm just highlighting so that you can see it carefully. So it is basically they are saying into multiply molarity and volume and divided by 1000. Okay, so I'm going to do this. So number of moles of HCl will be uh, 25, 25. So here is the number of moles of HCl I have written down. Now again I need to show you very carefully that this value, whatever highlighted value I have written down, it is strictly according to the rule I have laid down here. You can see this. This is the rule here I have laid down. Now, my journey is from this point to that point. Okay. So I am now multiplying this 25 volume. That is volume. So you can see uh, the volume of HCl. I have taken it here. This is the volume of HCl. The volume of HCl, and volume is here. This is the volume. And then that is the molarity. You can see this, and here is the molarity. And then divided by 1000. This is a 1000, you can see it here, and that is the 1000 I have written down. And you can see this operation will take you to the exactly to the mole. So this particular entire thing, when you'll do, it will give you the mole of HCl, and since the ratio is 2 is to 1, so it will be X. Therefore, number of moles of calcium carbonate X will be 2X is equal to 25. So therefore, X is equal to. So this is the answer, and we have done whole calculation strictly according to this chart. I have written it over there. Okay. Now let's move to the another example. Now our next question is, you can see chlorine is prepared in the laboratory by treating manganese dioxide, okay, with aqueous hydrochloric acid. According to the reaction, how many grams of HCl react with 5 gram of manganese dioxide? So now our job is to first write down the equation properly. So 4 HCl plus MnO2 giving 2H2O. So we have written down the equation. Now we'll see what sort of data has been given. Only the data given is about uh, manganese dioxide, that is 5 gram. Okay. Okay. And what they're asking for? They're asking for how many grams of HCl react. So basically they want HCl, but they want in terms of gram. Okay. So now again, what we'll try to understand that HCl and MnA2 bears the ratio, molar ratio 4 is to 1. So if I can calculate number of moles of MnO2, then HCl also can be calculated very easily by comparing that, whatever I have written down. So now, where we are now exactly present, let me show you. We are present in basically uh, given mass. Here basically. And this data is given 5 gram. Okay. Now your job is to reach to this particular point, mole. So to reach it, you can see this clearly. We need to divide. So now I'm going to divide it. Um, 5 gram divided by molecular mass MnO2, that is 87 gram. Okay. And it's to x. So therefore, x is equal to, so we get 0.22 moles of HCl. And if you want to calculate in terms of mass, then you need to multiply this 0.22 by the molar mass. Let me do it. So uh, this is the answer. So now we can uh, take another example. So next question is total number of valence electrons in 4.2 gram of N3- ion. So now there are various options given. Now we need to understand whatever data given, that is basically they have given in terms of gram. Okay, you can see this. So basically now you are present at this particular, at this point. Okay, now from this point, you need to reach to mole. Mole is like a junction to you. You need to reach to moles, and after reaching to mole, you need to go to the particle here. So you have to travel all the way at this point, and then you need to go to the subparticles. So from this point, you need to go here. So this is the total journey. This is a little longer journey than the all those previous sums that we have solved. So now, for that reason, first what we'll do, we'll first take 4.2 gram, that is the mass, divided by molar mass. What is the molar mass coming? That is 14 plus 14 plus 14. That is 42. So 42 has come. There is a number of moles. Here you have reached now. Here you have reached number of moles. Now, from the moles, you need to go to the particles. So you need to multiply by the Avogadro's number. Now you have reached here. Okay. Now, last part, that is, you need to go to the subparticles because they are not interested in molecules or atoms. They are interested in a number of electrons, and that is the subparticles. And valence electrons for this N3 minus total, there is 7. Sorry, that is, I think, total number of valence. Yeah. So it's a 5. 5 plus 5 plus 5. And for the negative charge, extra 1 electron will be there. So total 16 electrons, it will be multiplied by 16. So answer will come out to be 1.6 Na. You can say this. Okay. Now you can move to the next sum. Now you can look at this question. They are asking about a number of atoms. So calculating number of atoms means here basically the mass is given, that is here. You are basically at this point, okay. I think this color is not visible. Let me change it. You are here. You can see this. Okay. Now you need to travel first at mole, and after that you need to travel to number of molecules, that is particles, and after that you need to travel at this point. So our journey is like um, as longer as the earlier one, So let me do this sum. Um, so given mass is 4.25 gram. So you need to divide. You can say this. Uh, you need to divide it. Here the division sign is there, which is little not visible that much, but still there is a 17 will come. There is a you'll now you have reached to moles at this point. Okay. Now after that you need to multiply by the Avogadro's number, that is 6.023 into 10 to the power 23. That is the number of particles. It means you have reached to number of molecules. And then after that, you need to multiply with the total atoms present in the molecule. Even if there are four, so into multiply by four. So answer is coming out to be, so answer is coming 6 into 10 to the power 23. So option D is the right answer. Okay. So what I'm trying to say, although I have taken a little easier example so that you can have some idea how to use this chart, but I can assure you, you can solve all sort of problems uh, for mains, NEET, CT, of course, advanced also. So in the next class, I will take some more example, some difficult example, and we'll see how this particular chart can help us to solve those sums very easily. Thank you very much for today's class. So next, see you in the next class.